Hello everyone. Today I am going to discuss the fourth problem of Leetcode Weekly Contest 383, which is minimum time to revert word to initial stage 2. So the second problem of this contest is also same, but the constants are different. Here the constants on length of word is 10 to the power 5. There the constants was on 50. So what is the problem statement? We are given a string word and an integer k. Now at each second we can do this operation. Remove the first k characters from the word, from the string word, and add any k characters to the end of the word. Now we have to minimum time greater than 0 required for word to revert to its initial stage. So let's take one example. Let's take the first example one and understand what we can do and what we have to do. So here the first example I have written here. The string is ABA, CABA, and k equals to 3. Right now, what we can do? We can remove the first three characters from the word and add any three characters at the end. Okay, so let's say we have removed the first three characters and add something at the end. What we can add? Let's say we have added CAB. Okay, let's say we have added CAB. Okay, this is the first operation is done. At t equals to 1 second we have done this. Now at the second operation we can remove the first three characters again and add what? Add any three characters at the end. What we can add now? So now the string will be ACAB, and what we can add to make it similar to the first occurrence of word. The first occurrence of word is ABAC ABA. So this operation is not doing us any help. So let's check that we can build the string any other way, right? So let's say this is not possible, so I am discarding this. Now let's say our string is initially ABA CABA. How we can make this into the original string in 2 seconds? So we have to remove the ABA from the prefix of the word and add BAC at the end of the word. So they are saying that we have to add BAC at the end of the word. So let's say we have removed this and added BAC to the end of the word. Now CABA and BAC. Okay. So at the first second our string is like this. Now at the second, what we can do? We can remove the first three characters again. Now we have ABAC. Now if we added ABA at the end, our string will be exactly to the first occurrence of the string. First occurrence of the string, which is ABAC ABA. So you can see that at t equals to 2 seconds we can build the string again. Or what the problem statement says, that we are reverting the word to the initial stage. So our answer will be 2. Okay. So now how we can solve this problem? So let's jump into some observations, right? What is the observations for this problem? Now let's look at the constants. Now the constants on length of word is 10 to the power 5. So anything on order of n is possible, or possible time complexities could be also order of n log n, or here alphabets are included. So I am saying that order of 26 into n is also possible. So here are three possible time complexities for this problem. Now let's jump into some other observations, right? So here you can see that we are only removing the first k characters and adding at the end. Now let's say we have what is the maximum number of operations we can do? Okay, so the maximum number of operations that is needed, or what you can say that minimum number of operations, if we do that, the we will revert to the original string. So what will be that, right? So let's say we have something like this string only, ABA CABA, right? Now if let's say I have removed the first three characters and again three characters and again three characters, that means if let's say our minimum number of operation is, let's say, m. Now here I am saying if m into k is greater than or equals to n, then our answer is obviously possible. The answer will be m. If m into k is greater than or equals to n, then the answer will be possible. Why? Let's take some other case, right? A B C D and k equals to 2. Okay, here no characters are matching, so there will be at the first time we will remove the first two characters and add something at the end. So we'll add AB at the end, right? So we have to add the same thing at the end. Now at the second operation we will remove the first two characters again and add CD at the end. So here you are saying seeing now what we can do to get m into k is here k is m is 2 and k is 2. 2 into 2 is greater than equals to 4. So that's why we are able to achieve our initial string at m equals to 2 operations, right? I hope you get it. So the seal of the number of operations should be uh, n by k. So here I can say that m should be greater than equals to k by n. Okay. So the k by n is the seal of the operation. That is our first observation. Now what is the second observation here is that, let's say anything which is less than m, anything which is less than m, let's say here m is 2 here, right? Now let's say m is 1, then the last k characters are getting untouched, right? So what I am saying that at the first operation, let's say our string is like a b c d e f g h. Now at the first operation, after the first operation, the last 6 characters are untouched. At the end of second operation, the last 4 characters are untouched, and at the end of the third operation, the last 2 characters are untouched. So what I am saying is that at the end of the first operation, n minus k into I number of characters will be untouched. Okay, last n minus k into I number of characters will be untouched after ith second. Okay, so what we can say, what our observations we can do is that if the last n minus k into I characters are matching with the first n minus k into I characters of the string, so let's say our string was abcd abcd, right? abcd abcd. So what we can say that if the last 4 characters and the first 4 characters are same, then what we can say, after doing the first deletion of the first 2, we can add these 2 at the end to get our desired answer, right? So here I am saying that we will check for every n minus ki characters if the first n minus ki characters and the last n minus ki characters are same or not. If they are same, our answer will be this, and if no, then we will move to our next type, right? So let's jump into the code now. Here for the easy version of the problem, let's go to the easy version of the problem. That will be better. The second problem, you will understand it better. Here what we are doing, we are iterating over our initial I is 1, and we are iterating over every value of I, and we are checking that the first L characters are same sorry yeah, the so what we are doing here is that let's say we are at some index I, right? So we will check that the remaining characters, let's say the number of remaining characters is L, we will check the suffix of length L is equals to the prefix of length L or not. So here we are doing that the first L characters or prefix of L characters, prefix of length L is similar to the suffix of length L or not. If it is same, we will return C. Otherwise, we will increment the value of C and we will check the next n minus ki, right? So here C is our I. So you can say k n minus k into C, right? So let's see that how we can solve this problem with greater time complexity. So for solving this problem with greater time complexity, here you can see that we are comparing the prefix of length L and suffix of length L. So we can use some string hashing to solve this problem. So if we try to compare two prefixes and suffixes, it will be order of n operation. So we can make it order of 1 using string hashing. So how we can do that? So I have explained it in my previous videos, but still I will going to explain you that how we can do string hashing. For kind of rolling hash, what we are doing, that our hi will be let's say hi is the hash of the string of prefix I, right? Hi is the hash of prefix I, hash of prefix I, right? Prefix of length I. Now how we are calculating hi? So let's say our string is like a b c d. So what we are doing is that we will have two variables. One is base, let's call it as 26 because we have 26 alphabets, and we have something mod, let's say it is 10 to the power 9 plus 7. Mod will be some high value. So what we are doing, hi will be nothing but our previous value of hi minus 1, hi minus 1 plus current si, the alphabetic value of si into base to the power I, and whole thing will be under a mod, under mod m, right? That is our value of hi. So let me write it in text format, that will be better. So let me delete this. Now I have written the definition of hi. Hi is I have already told what hi is. Now we how we can get h of I to j, how we can get h of I to j. Okay, so here you can see that if we take the sum of all values from h, we will have hj, we will have hj is the hash of prefix till j. Now if we delete h of j to h of I minus 1, we will have something like this. We have some, we'll be having something like this. Let's say si into base to the power I plus dot 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 sj into base to the power j, right? We'll have something like this, si into b to the power I. Now let's say if we have divide this, if we divide this by b to the power I, we'll have something like si plus dot 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 s of j into b to the power j minus I. Okay, now if we take it modulo m, we will have the hash of I to j. Okay, so that's the algorithm to calculate the hash of I to j. We will take the difference between hj and hi minus 1, and after that we will divide it by base to the power I. Okay, now let's jump into the code. Yeah, so here we are calculating the power of I. Power of I is nothing but base to the power I. Here I have taken base 31, you can take 26 also. Now uh, here I am calculating the value of hi. Hi is nothing but hi minus 1 plus bo means nothing but our the ASCII value minus the ASCII value of a plus 1. Here you have to consider that for a we have to take the the value as 1, not 0, but because that will fail, right? So here I am calculating the hash of substring I to j. So we are calculating the inverse of power for power of pi, because we are dividing it by power of pi. That's why I am taking the modulo inverse of that of mod. Now returning, I am returning hj minus hi minus 1, dividing it by power of I and taking it modulo mod, right? And for the rest of the algorithm is similar to the second case, that we are taking l as n minus 1, and we are checking that the prefix of the hash of the prefix of 0 to l minus 1 is same as the suffix or not. If it is same, we are returning c, and if it is not same, we are incrementing the value of c and moving to the next operation. I hope you get it. I will provide the link of the code in the description box. If you have any doubt in any part of the video, you can always write in the comment section. If you find this video helpful, please like the video and subscribe to my channel. Thank you.